Okay, so the next thing that we have in this chapter is the miscellaneous exercises on chapter 10. And so basically we have a question over here. And that is basically we have this equation over here, k minus 3 times x minus 4 minus k squared times y plus k squared minus 7k plus 6, and basically you want to find the values of k. You want to find the values of k for which the line is parallel to the x-axis or parallel to the y-axis, or basically passes through the origin. So now if that's supposed to happen, so you see that basically k minus 3 over here is this is the coefficient of x here, and we have some coefficient of y over here, and then we have some k's over here as well. So we have k squared minus 7k plus 6 we have over here as well. So then if a line is supposed to be parallel to the x-axis, if the line is supposed to be parallel to the x-axis, it's of course the slope of the line has to be the slope of the x-axis. And you see that over here if I have a line that is parallel to the x-axis, for example this line over here, if this is x and this is y, if I have a line over here that is parallel to the x-axis, you know that the slope of the x-axis is 0. So what that means is that if I denote the equation of any line in the xy plane as ax plus by plus c is equal to 0, and you know that the slope of the line is basically negative a by b, then that means that basically your slope has to be equal to 0, because that is the slope of the x-axis. M has to be equal to 0. That means that negative a by b has to be equal to 0, and that means that negative a has to be equal to 0, which means that a has to be equal to 0. Now and you know that a is the coefficient of x over here. Now if I take if the coefficient of x is 0 over here, you can see that x is not there in the equation anymore, and then you will get some equation like, for example, by plus c is equal to 0, and then you will get by is equal to negative c, and then you will get y is equal to negative c by b. And usually, all the time, whenever you have a line that is parallel to the x-axis, the equation of the line becomes y is equal to some constant. For example, y is equal to 2 would be this line over here, or y is equal to negative 2 would be this line over here. This is y is equal to negative 2, and so on and so forth. So the lines that are parallel to the x-axis are denoted by this kind of equation, and that's basically why it happens. Now if I take my And one more thing that we need to basically discuss as well is that if a line is supposed to be parallel to the y-axis over here, let's say that this is the y-axis and this is the x-axis. If I have a line that is parallel to the y-axis, in the case of this line, the slope of the line has to be the slope of the y-axis. And you know that the slope of the y-axis, is basically undefined. Now, if I have a line, for example, ax plus by plus c is equal to 0, the slope of this line is basically negative a to b, is equal to negative a to b. Now, this m, if this line has to be parallel to the y-axis, basically the slope of the line has to be the slope of the y-axis, which is undefined, so this has to be undefined, meaning that negative a to b has to be undefined. And what undefined means is that you're basically, for whatever reason, you're dividing by 0. And so what that means is that your b has to be equal to 0. Now, if your b is equal to 0 in this equation, if b is equal to 0, what you will get is you get ax plus c is equal to 0, or you will get ax is equal to negative c, or you will get x is equal to negative c by a. And of course, always whenever you have some line, basically some vertical line, the equation of the line is, for example, x is equal to 2, or x is equal to negative 3, and so on and so forth. And of course, you know that, for example, the equation of the y-axis itself is basically x is equal to 0. X is equal to 0. So that is basically what happens in the case of these lines over here. Now that we know basically this much about these lines, now I can go and basically solve this problem, which means that the first part, the line has to be parallel to the x-axis. So we said that if the line is parallel to the x-axis, it has the same slope as the x-axis, which is 0. That means that negative a by b, which is the slope of the x-axis, has to be equal to 0. And so that means that a is equal to 0. Now, if a is equal to 0, that means that k minus 3 is equal to 0. And that means that k is equal to basically 3 over here. If k is equal to 3, then this line is going to be parallel to the x-axis. This is part 1. And part 2, we said that if the line has to be parallel to the y-axis, the slope has to be undefined, meaning that negative a to b, which in this case is basically k minus 3 over, of course, negative k minus 3 over negative of negative 4 minus k squared, negative 4k squared, and these two can cancel out. This has to be undefined. And for this to be undefined, of course, the denominator has to be 0. So that means that 4 minus k squared is 0. That means that negative k squared is equal to negative 4. And you can cancel these two out, and then that gives you k is equal to plus or minus 2. So that is basically for the second part. Now the third part, we want the line. So the first part over here, I write it over here so I can have some space. So k is equal to 3 over here. That is the first part. So for the third part, what you want to do is basically you want the line to pass through the origin. So if the line has to pass through the origin, that means that the origin is 0, 0. That means that this point has to be on the line. That means it has to satisfy the equation. So if that's supposed to satisfy this equation, that means that you put x over here and y over here, so both of these parts are 0, and so you have basically k squared minus 7k plus 6 is equal to 0, which means that 1 and 6, so if you write 1 and 6, 1 plus 6 is equal to negative 1, negative 6. So I can write this k squared minus k minus 6k plus 6 is equal to 0. And I can write this as k times k minus 1, negative 6 times k minus 1 is equal to 0. That means that k minus 6 times k minus 1 is equal to 0. That means that k is equal to, that means that either k minus 6 is equal to 0, or you can say that k minus 1 is equal to 0, and this means that k is equal to positive 6, or you can say that k is equal to positive 1. That is basically the two different values of k. That is basically the two values of k for which the line goes through the origin. So let me take a look at the solutions. So part A is basically k is equal to 3 plus or minus 2, and then over here you have 6 and 1. So hopefully you have understood the logic here, otherwise the answers are not that important really. So question number 2 is find the values of theta and p if the equation x cos theta, x times cos theta plus y times sine theta plus y times sine theta is equal to p is the normal form of the line, is the normal form of the line square root of 3 times x, square root of 3 times x plus y plus 2 plus y plus 2 is equal to 0. So if this basically if this equation over here is the normal form of this line, then find the values of theta and p, meaning that you just want to, what it means is that you want to write this line in the form of in the normal form basically. Okay, so now the way that you can write this equation in normal form, basically. Okay, so I realized that we needed to go back and do some, basically repeat a couple of things to basically understand this normal form. So of course you know that the normal form of the equation of the equation ax plus by plus c is equal to 0. The normal form of this equation was basically, we said that, for example, let's say that you have this line over here. If you have this line over here, we said that if the length of the perpendicular from the origin is p and this angle is omega, we showed that we calculated some slope for this line based on the slope of this line, which is in terms of tan omega, and then we got some slope for this line, and then we also calculated, for example, the coordinates of this point on this line based on some triangle that we had over here, and then and then basically we used y minus y1 is equal to m times x minus x1, and we wrote some equation for this line as x times cos omega plus y times sine omega is equal to p. And then we said that basically using some calculation we also showed that basically if you write this equation, and since both of these equations represent the same line, abstractly they represent the same line, you can write x times a plus y times b is equal to negative c. So then I can write, then since these two again represent the same equation, so the ratios of the coefficients of x and y and the constants are equal, meaning that you can say that basically a over for example cos omega is the same thing as b over sine omega is the same thing as negative c to p. And so that means that basically cos omega times basically that gives, basically if I take these two parts together and cross multiply, I'll get negative c cos omega is equal to ap, or you can say that cos omega is equal to negative ap to c. And if I take these two parts together, I can write negative c times sine omega is equal to b times p. That means that sine omega is equal to negative b times p over c. Now you know that basically you do know that sine squared theta plus cos squared theta is equal to 1. So you can write basically sine squared omega plus cos squared omega is equal to 1, which is equal to negative ap by c whole squared plus negative bp by c whole squared. So that means that basically these are basically all that you can say that negative ap by c whole squared plus negative bp by c whole squared is equal to 1. And so if you add these two together, you will get basically a squared p squared, and of course this is a lowercase p. You will get a squared p squared over c squared plus b squared p squared over c squared is equal to 1. And what that means is that basically c squared, and over here you have basically p squared times a squared plus b squared is equal to 1, and that means that p squared times a squared plus b squared is equal to c squared, and so p squared is equal to basically c squared over a squared plus b squared, and so that means that p is equal to plus or minus the square root of c over the square root of this, which is written as, well, you can write this as c over square root of a squared plus b squared. So that is basically, for example, the value of p here. And then, for example, over here, cos omega, which we calculated as cos omega over here is equal to negative a p to c. So for example, again, you can calculate cos omega here. So over here we said that cos omega is equal to negative ap to c. So we said that cos omega is equal to negative ap to c. Now p is equal to this thing over here, and a is, so I can write this as c. I have a c over here, so a is basically a. I don't have to worry about that. And p is basically plus or minus this. So I'm going to write it down here. So this is equal to basically a times, so p is plus or minus basically c over square root of a squared plus b squared, and you have basically a times this, and then you have to divide this by c. So so then c and c will cancel out. So then you have cos omega is equal to plus or minus a over square root of a squared plus b squared. Right? And with the same logic, you can say that sine omega is equal to plus or minus b over the square root of a squared plus b squared. So this is all of the information that we had before. Now, when you want to basically when you want to convert a line from the general form to the normal form, what you want to do is that, as you saw before, it doesn't really make any sense to calculate each and every one of those things. For example, it doesn't make any sense to calculate each and every one of those things. For example, we know that for example, cos omega is equal to, for example, plus or minus a over the square root of a squared plus b squared. And for example, I don't know, the sine omega is equal to plus or minus, for example, b over the square root of a squared plus b squared, and so on and so forth. And the reason for that is that basically in the equation that I have ax plus by plus c is equal to 0, and so, and in the normal form I have basically cos x times cos omega plus b times plus y times sine omega plus basically is equal to p. Okay, so you see that a, for example, you see that, for example, cos omega is nothing but a divided by the square root of a squared plus b squared, or over here sine omega is the same thing, meaning b divided by this thing over here. So you don't need to do much really. All that you need to do is basically find the square root of a squared plus b squared in the case of the particular equation that you have, and then simply divide the whole equation by that. And well, that practically means that you have found the value of, for example, a divided by the square root of a squared plus b squared, and this one, and so on and so forth. And then you've written a new equation using basically that information. So that is basically the whole story. Now, if you have some equation like, for example, the square root of 3, if you have some equation like the square root of 3 times x plus y plus 2 is equal to 0, So all you need to do is find the square root of a squared plus b squared, which is, in this case, is basically the square root of a squared, which is square root of 3 whole squared, plus b squared, which is 1 squared. And then this is equal to the square root of 3 plus 1, which is equal to the square root of 4, which is equal to 2. So you can simply divide the whole equation by 2, meaning that you can write the square root of 3 over 2 times x plus 1 by 2 times y plus 2 divided by 2 is equal to 0. And that is the square root of 3 by 2 times x plus 1 by 2 times y plus 1 is equal to 0. Now what you need to do here is that basically these have to be expressed in terms of, and of course this has to go to the other side of the equation, because this is your p. Now you need to pay attention to what happens here, and first take this one to the other side and see what happens. And the reason for that is if I write square root of 3 by 2 times x plus 1 by 2 times y is equal to negative 1. Now you see that basically this p, which is supposed to be a length, meaning that it's supposed to be, for example, the length of this line, the length of this perpendicular line, which is p, this length over here, is a negative number, which is, well, of course, not supposed to be like that. And of course, if you don't take care of this, your angles will be simply messed up. You won't get the right angles over here based on these coefficients. So what you want to do is that now that you see that this number is a negative number, you want to multiply your whole equation by a negative 1. You get negative you get negative square root of 3 by 2 times x minus 1 by 2 times y is equal to positive 1. Now this 1 represents your p, which is basically the length of the perpendicular from the origin. And now okay, so now basically what you need to do is, basically, as you know, the coefficient of x is cos theta or cos omega. The coefficient of y is sine omega. So you know that basically cos omega is equal to negative square root of 3 by 2, and sine omega is equal to negative 1 by 2. Now you're looking for some angle whose cos is, and cos and sine are both negative values, and the cos of that angle is, well, ignoring the sines, is square root of 3 by 2, and the sine is 1 by 2. So this is somehow related to 60 degrees, because in the unit circle, when you have 60 degrees, now again ignoring the sines for now, when you have 60 degrees, the sine of that angle, I'm sorry, this is not 60 degrees actually. So the sine of that angle, ignoring the sines, is 1 by 2. The cos is square root of 3 by 2. And this is somehow related to 30 degrees. Because in the unit circle, what you have is that when you have some angle 30 degrees, again ignoring the sines for now, you have basically, if you have a 30 degree angle here in the first quadrant, you know that sine 30 degrees is equal to 1 by 2, and cos of 30 degrees is equal to square root of 3 by 2. Now, this angle has to be somehow transported to some other basically quadrant in which both the sine and cos are negative. And what that is, basically, if you come over here, you will see that basically your sine is still positive, your cos is negative. Over here your cos is negative, your sine is negative, and over here your cos is positive, your sine is negative. So you have to come somehow over here. Now if I draw this angle over here, exactly producing this line segment over here that makes the 30 degree angle, I will have basically produced a 30 degree angle over here. And of course you can see that the cos of this angle is of course the algebraic opposite of the cos of this angle, and exactly the same quantity, meaning that if this distance over here is the cos of this angle, and it's exactly equal to this distance over here, and the sine of this angle is basically this distance over here, the sine of this angle is this distance over here. So these are exactly equal, the sines are exactly equal, the coses are exactly equal, with the only difference that the sine over here is positive, the sine over here is negative, and the cos over here is positive, the cos over here is negative. So you want to find basically 30 degrees plus 180 degrees, and that's the angle that you're looking for. So 30 plus 180 is equal to 210 degrees. 210 degrees. And of course, if you use the formulas related to geometry, meaning that, for example, there are all of these formulas in trigonometry, like for example cos of, for example, 180, or they're usually written in radians. So for example, you have the cos of pi plus theta, and you have, for example, the sine of, I don't know, pi plus theta. You have the cos of, for example, pi minus theta. You have the sine of pi minus theta, and so on and so forth. You will have the same results over here. But again, these kinds of formulas I'm not very comfortable with these, because you have to memorize them, and I don't really memorize anything unless I have to memorize it. But sometimes they are useful when you're doing trigonometry using algebra. When you're doing trigonometry using algebra, of course they are useful and valuable. But when you're doing something simple, for example finding some angle, I find this method much easier and much more straightforward, as opposed to using some formulas. I'm not really, and of course I would write these formulas, for example, on a piece of paper and put it in my, for example, notes related to trigonometry, and then I would use them whenever I had to. I couldn't really memorize these formulas, and although we were required to memorize these formulas when we were in college. But well, I'm not in college anymore. I'm not writing any exams. I'm just interested in mathematics itself, really. So basically, then you could meaning that you could also use these formulas, and I don't know, sometime if we find that the relevant place, we will derive all of those formulas, and I need to do that myself and put it in my own notes as well. But for now, you know that this angle over here, for example, is the angle you're looking for. So then you can, instead of negative square root of 3 by 2, you can write instead of negative square root of 3 by 2, you can write cos of 220 degrees. You can write x times cos of 210 degrees. And instead of negative 1 by 2, you can write sine of plus, of course, plus sine plus y times sine of 210 degrees, because this sine of 210 degrees is a positive, is positive itself, is equal to 1. And so that will take care of the problem. So I suppose that is the required equation for the line. Let me check the solution here, number 2. So over here we were supposed to calculate the value for theta, which is basically the same thing as omega here, and p. So the value of p is 1, of course, and your theta is 210 degrees. Now 210 degrees in radians is, you need to convert it. So you have basically, you can convert using that circle, or you can convert using the formula. Sometimes the circle is better. So we said that over here we had 30 degrees, and then the angle was over here. So over here this is 30 degrees, so this is, and you know that 30 degrees is pi by 3. Is pi by 3. So this is pi by 3. So this is 1 pi by 3, 2, 3, 4, 5, 6, 7. So that means that this angle is 7 pi by 3. Or you can basically, using the circle, you know that this is pi by 3 and this is pi radians. So pi by 3 plus pi is equal to basically 3, and then you have pi plus 3 pi, which is equal to pi plus 3 pi is equal to 4 pi by 3. Okay, so let me see. Well, actually I did make a mistake here, and I was basically kind of surprised to see this result. So basically the angle basically 30 degrees is in radians, it would be basically pi by 6, because pi by 3 is basically the same thing as 60 degrees, because you know that pi is equal to 180 degrees, so 180 degrees divided by 3 is equal to 60 degrees. So pi by 3 is 60 degrees, and 30 degrees would be pi by 6. This is wrong. So now pi by 6 is basically 30 degrees. So again you can count, because there is in each quadrant there is 3 pi by 6's, because each quadrant is 90 degrees, and that's 3 times 30 degrees. So you have pi by 6, 2 pi by 6, 3 pi by 6, 4, 5, 6, and 7 pi by 6. This is 7 pi by 6. or you can basically simply calculate, meaning that you can write pi by 6 plus pi, which is equal to 6 and pi, and that is basically 6 pi, and that is 7 pi by 6, which is basically the angle that we are looking for. And there is one more way to calculate, to convert, and that is basically, you know that basically pi radians is equal to 180 degrees. So that means that then once you have basically 210 degrees, you want to know what is 1 degree. So 1 degree, basically 180 divided by 180 degrees is equal to pi divided by 180 radians, right? So that means that 1 degree is equal to pi divided by 180. And so 210 degrees would be basically, so based on this, 210 degrees would be equal to this times 210. So that would be basically 210 times pi over 180. And then you can write this as 2118. Divide by 3, you will get 7. Divide by 3, you will get 6. And so that is 7 pi by 6. That means that 210 degrees. That means that 210 degrees is the same thing as 7 pi by 6 radians. Okay. So that's all the different ways that you can convert here, and then then you will write you can write the equation of the line as, for example, cos of 210 degrees, or sometimes, I don't know, I have not ever seen any equation written in radians. That must be also possible, but I have not seen any instances. So basically, so far I have written all of my equations in degrees. And that's basically the whole story here about question number 2. And you can see that basically I take all the time, and basically for 2 questions I've taken like 42 minutes to basically go through everything that I need to go through, because if you miss something here, basically mathematics is always like this. If you, it's for example, let's say that you start from class 6 and you want to basically go all the way up to, for example, class 12, and then basically when you go higher, for example, then you have basically probably 3 or 4 mathematics books in any university course that you do. For example, you do some engineering course, or you do, of course, if you study mathematics, of course, you will have more mathematics books in a typical course that you would do. But typically you have to go from class 6 to 12, and then you would have 1, 2, and 3 books, probably 3 or 4 major books in any typical university course. You have to start from here, and you don't want to miss anything along the way. If you miss something, you have to go back and see what you missed there and take it, and then you can very easily get to, for example, a graduate course or undergraduate course, or whatever it is that you want to go, or wherever it is that you want to go. But if you rush yourself, you will get lost. It's not a good idea in mathematics to get ahead of yourself. You don't want to do that. So take all the time that you need to go through all the definitions, all the different ways of solving problems, and so on and so forth, so that you don't get yourself into trouble. And once you do this way without rushing yourself, it will actually be a lot of fun. This way it will be a lot of fun. But being always in a hurry, it's actually not I mean, not the best idea, really. Okay, so we have the third example over here that we will go through as well.